make a start. Okay, so welcome everybody. Just going to give a brief kind of introduction. So first of all, if you could put your questions into the Q&A box, not the chat box. I have put in the chat box a little Word document, and in that is just a list of kind of questions that me and Jeff were kind of swapping, which prompted us to run this webinar. Now, I'm going to ask everybody in the panelists here to just briefly introduce themselves. And then after which Jeff, who'll be the last one to introduce himself, will just show a small number of slides, which will cover a couple of basics, but we are assuming that you have some basic knowledge about embodied carbon accounting. However, if we're missing stuff, basic stuff that you really want to say, hang on, I'm getting really confused, put it in the Q&A and I will pull those out and we'll kind of steer the conversation to make sure that, there's a lot of questions about some fundamental concepts that are confusing people. We'll stop and sort of cover those. Okay, so in terms of like this sort of that Word document in the chat, the sort of concepts that we want to sort of chew over, concepts of lifetime carbon, upfront carbon, issues around the end of life of buildings and materials, and look a bit or think a bit about targets and even standards for decarbonising materials. And I think we might touch a bit on whether, some construction sectors, steel, concrete, whatever, are easier or harder to decarbonise. And there might be a question there, for example, are some existing construction methods not even worth trying to decarbonise because they're so inherently difficult to decarbonise? And if we're, faced in a maybe 10, 20, 30 years of trying to build, perhaps we should be abandoning some of those methods now and concentrating on the easier to decarbonise materials. So without further ado, I run the AECB, and then half the week I'm an ecologically minded designer with Simmonds Mills. So my particular interest in this is I do and have been trying to find lower carbon methods for constructing buildings, but I'm lazy and I want other people to do the hard modelling work. And I don't particularly want to have to do this modelling work on every project. I want to build up a sort of library of methods and details that just allow me just to get on and quickly start implementing those lower carbon ways of designing and building. Tim, would you like to go next?
Yeah, I'm Tim Martel. I am the author of Software pH Ribbon, which is the AECB software on embodied carbon and operational carbon. About 10 years ago, I qualified as a passive house designer and been involved in passive house ever since then. Also, about 7 years ago, I worked for a few years preparing for the retrofit course that the AECB does. I'm a tutor and I'm also an expert advisor for the AECB. So on the score of retrofit, I'm also quite accomplished on that. I'm a retrofit coordinator as well. And I also have a background a lot further back in programming, in spreadsheets, in the very language that we need to use for PHPP. And so I brought all that together in order to create pH Ribbon.
Okay, thanks, Tim. That's great. Somebody's told me that the chat's been disabled, so they can't get the document, but we'll sort that out. So keep an eye on that. John Butler, would you like to go next?
Hi. Yeah, so I'm also a passive house consultant, designer, and started describing myself as geek for hire because it sort of describes what I'm doing mostly, which is partly passive house calculations on new builds and retrofits, and now increasingly embodied carbon calculations using Tim's pH Ribbon tool, and combining all of that together, looking at different ways of retrofitting and the carbon impact of different ways of retrofitting and the energy impact and comfort impact. And yeah, looking at all that together, really. I think that's pretty
Great.
much me.
Thank you,
I'm
John.
mostly plugging away on my computer and occasionally get to go and see real buildings.
John, your microphone is just booming, reverberating a little bit. Maybe you could see if you can adjust that in your spare moments. Jeff, over to you.
Okay, thanks, Andy. Yeah, so I'm Jeff Colley. I'm the editor and publisher of Passive House Plus magazine. I'm sure many of you will know we're an AECB affiliated green building magazine. Our whole shtick really has been about trying to quantify the impacts of sustainable building and try to present this stuff in terms that somebody with quite a simple brain like myself can understand, and therefore hopefully give other people a chance to understand. Like, I think for me that's one of the absolutely critical elements of something like embodied carbon. It can seem frightening and nebulous as a subject, and we need to be able to present it in a way that doesn't scare people off. I certainly was very intimidated by it when we started looking at it as a subject. I'm going to share a couple of slides to I presume this everybody can see this, yeah? Hang on a second. Go back to where, yeah. Basically, this is the table that you see. The standard kind of table showing the life cycle stages that you have in embodied carbon calculation and life cycle assessment of buildings. I've added these headings at the bottom, and for anyone who wasn't at the AECB conference, we have videos filmed from the conference. One of which was on my presentation, which was like an idiot's guide to embodied carbon. It might be worth checking out for people. We can send a link around, I'm sure. We can put it in the chat afterwards, and it kind of tries to simply explain the basics of embodied carbon calculation. When I first saw these tables, I found them very intimidating. The three kind of essential components with embodied carbon calculation in terms of stages are modules A, which is the two kind of, I guess, sections on the left there, modules B and module C. A is the upfront emissions, and I described that as kind of conception and gestation. B is the use phase of the building, and that includes, you'll see B6 and B7 there, which is operational energy use and operational water use. There's a note on that which is worth adding, is that when you have targets like the REBA 2030 climate challenge targets, which are worth reading and worth trying to design to and try and beat, B6 and B7 are not included in the embodied carbon totals for buildings. They're reported separately. All of the emissions arising from energy use by the building, for instance, and from water use are reported separately. And then C1 to 4, the module C, which is the end of life phase. So that's, what happens to the building, what we expect will happen to the building at the end of its life. And then you've got module D there, you'll see behind the dashed line separately, which I described as kind of grave robbing, and that's not included within the targets for buildings. That's potential future uses of components from the building. So it's like this kind of, like Igor, Dr. Frankenstein's grave robbing assistant, taking body parts out of graves and trying to make something new out of it. So that's essentially the stages. It's useful to think in terms of those those kind of basic principles. I would say module A for me, we can talk about this more. Module A is the one that we can have most certainty, most confidence about, because we've got increasingly we've got good quality data emerging. Like environmental product declarations, independently verified data on the total embodied carbon that went into manufacturing a given product. So that gives you some degree of confidence in the assumptions that when you have that kind of data, and you have EPDs now for many common construction products, and they're more and more all the time. It's kind of spreading like wildfire. And then you've also got the assumptions around the construction process and transport to site, which tend not to be massive chunks of the total. When you get to module B and module C, you start having to make assumptions about how long components will last, and about how polluting the manufacture of replacement components will be, whether it's in 10, 15, 25, 30 years time or so. It's useful and important to think about that kind of stuff, but you know, you end up starting to make assumptions which frankly we don't know the answers to yet. And the same thing applies with module C. We don't know how long the building is going to last, and we don't know what's going to happen at the end of life. Just quickly, a couple of more slides. There's an article that we published in issue 38, which is all available digitally on our website for free as well, by the way, called 6 of 1. And this is based on analysis. I badgered the Passive House Association of Ireland, which I'm a board member of, to commission the AECB to do some analysis in this regard. And the AECB were commissioned to do this analysis using pH ribbon. I'd encourage everyone to look to use that tool if they haven't. It's dirt cheap, and if you've used PHPP, the beauty of it is that it does an awful lot of the heavy lifting. If you've done PHPP calcs, it makes it much quicker and easier to do embodied carbon calculations. This was an end of terrace council house provided by Cork City Council. It's a small enough house. I can't remember exactly whether it was 80 odd square meters, something like that. And Tim did the analysis with Andy, an architect who's a member of the Passive Association, called John Moorhead, and myself. We looked at 6 different wall types, and the variables that we focused on were the wall types and the foundations, with 2 cavity wall variants, both with strip foundations, the difference here being either rendered blockwork or brick. And then we had external insulation, either with insulated foundations or strip foundations. And then we had also external insulation with a brick slip finish, and then finally an I-beam timber frame with cellulose and a render board. And then arising from that final point, I'll shut up now. Sorry, was in fact no, sorry, I don't need to go into that. We expanded upon that with some work with the Irish Timber Frame Manufacturers Association in an article in issue 41, which added more wall types into the mix and just focused on the wall type. So we have an apples with apples comparison of 11 different wall types, showing the embodied carbon in each case, which I think is really, really useful.
It's interesting this because we did end up with quite a nice low carbon timber frame wall version of this, sort of cantilevering off that reinforced concrete slab there. But some projects you kind of I still hanker for that solid masonry inner load-bearing element, and putting something on the outside of it because of the ease of fixing and the simplicity of the construction, the lack of layers and so on. So it's not like I don't feel quite ready to abandon some of these things, which is interesting. So shall I put up the I don't know, I think Pat Borer is the only person who seems to have not managed to get this Word document. I'm assuming, unless I hear otherwise, you've all had a chance to look at those questions separately via the chat box document. So I'll assume that that's the case. How about, Jeff, that I just sort of go through these questions one at a time, or we can chew each one over? I know they might be sort of interlinked and so on, but should we do it like that?
Yeah.
Okay, so the first one we've got here is a question about the importance of embodied carbon. I think there's still a little bit of, I would say, confusion or debate, maybe it's more confusion as to how important embodied carbon is. So if I just quickly share, if I just share one slide, which is this AECB slide from Tim will recognize this because he created it. So this is the AECB stock model, a sort of polished, basically an Excel spreadsheet, and that's looking at the English housing stock cut a long story short, what we're exploring here is if we apply various retrofit standards and apply various new build standards to the new buildings going into the stock, we're looking at how are we likely to be able to bring down the operational energy, the greenhouse gas emissions from space heating. And so the graph on the left shows applying various AECB retrofit standards and with a smattering of benefits and so on in terms of the greenhouse gas emissions from space heating. And on the right is a similar thing, but where we don't decarbonize the materials which we are applying to those buildings, the insulation and the new windows and so on. So on the left, the bottom sort of 3 or 4 lines there, that shows you the emissions from the materials used to retrofit, assuming a progressive decarbonisation of those materials. So steel becomes less carbon intensive, insulation becomes less carbon intensive, and so on. On the right, that's what happens if we don't decarbonise the material. So obviously, it's not the dominant factor. Operational space heating demand is dominant, but it is obviously very important, and we can't ignore it if we're looking for fast, rapid, or even not fast and rapid, but some significant reduction in greenhouse gas emissions from heating. So that's our position. Jeff, you sort of raised this issue in the Irish context, hadn't you?
Yeah. We have there's a report that the Irish Green Building Council, I'm a massive fan of. We work a good bit with them over here, and they commissioned a report a while ago called, where is it gone? Building a Zero Carbon Ireland, and it's just part of the work they're doing on embodied carbon. And that report, which was done in collaboration with University College Dublin, were estimated that about 14% of Ireland's total emissions are embodied carbon into the built environment. 14%, yeah. Operational was 23%. Operational emissions associated with heating. The way they described it in the report was heating, cooling, and lighting, I think. So I think I presume it's the non-plug loads, like the regulated energy use. I'm guessing.
I presume we can't do. I don't know whether this group of panelists broadly agree that we shouldn't be thinking about trade-offs between reducing operational space heat demand and decarbonising materials. It should be both. Would you agree with that, John? What's your view on this relative importance?
I think both are important. We need to do both simultaneously, otherwise you reduce the amount of decarbonisation that you can achieve, basically, if you're not looking at the whole picture and decarbonising both kind of energy sources and material emissions, and at the same time reducing the amount of energy that you need, full stop, even if the sources of that energy are also decarbonising, because we don't want to kind of decarbonize, say, our heating, but increase the amount of electricity that we use to do that, and then place too much demand on the grid. So you can't. I think you've got to look at everything. And I mean, a side effect of reducing your operational energy and carbon emissions is that you make much more comfortable houses and reduce people's heating bills. So it seems like a win-win.
I suppose the place that's challenged is often heritage buildings, listed buildings, where for various reasons, not all of which I'm particularly happy about when we come face to face with them, reducing space heat demand is difficult to impossible. And so it really pushes, you do perhaps end up having more conversations about decarbonising the materials. What does irk me is where the conversation starts there, where heritage officers might be saying, some, not all, obviously, might be saying, imagining that you can do a huge amount to work towards, these sort of decarbonising our lifestyles, the way we go about doing things, simply by choosing some natural materials. I do find those sort of conversations really challenging. Tim, what do you think about the relative importance of embodied versus operational?
I think you've got it, really. The primary thing is operational to start off with. you've got to nail the operational by, say, having a heat pump, because that's going to decarbonize with the grid. And once you've done that, you can start addressing the embodied carbon. And there's quite a long way you can go with the operational before you look at the embodied carbon. But the embodied carbon is definitely the next thing on the list. And so.
But what's interesting about what you just said, of course, is that you didn't mention fabric there. What you said was decarbonize the operational energy by using the inherent efficiencies of a heat pump rather than immediately go to the deep retrofit. I mean, this is, our position on this is why we've developed the AECB level 1 retrofit standard, which is a lighter retrofit with the heat pump. And really, what the fabric is doing is then managing the costs of the heat pump.
Exactly, yes. I mean, that opens up a wider understanding of the whole process. You go to a heat pump, but in order to make the heat pump viable and to give you the comfort you need, it makes a lot of sense to do a good retrofit. And therefore that expands that whole area about doing a retrofit and gives you a purpose and reason to do that.
Yeah, thanks. There's a question come in which probably is kind of pertinent to a lot of these things, but I'll bring it in now. So Ken Neal is pointing out, this issue of lifetime, building lifetime, component lifetime, and he says people often attribute a life of 30 to 50 years for buildings. The most popular houses in the country are 300 to 400 years old. As we are supposedly designing top-end passive houses, why shouldn't they be in existence in 300 years' time? They will certainly be more popular than standard built houses even in a few years' time. So this issue of the accounting, how this affects our thinking, if you were to show the proportion of operational energy versus embodied carbon for 1 year, so the upfront carbon emissions versus 1 year of operational heating, say, relatively speaking, embodied carbon will look hugely important. And I don't like seagrass like that, because that's sort of misrepresenting, it's giving a false sense of perspective. But at the same time, if you show a building lasting 300 or 400 years, then obviously the opposite will be true, won't it? It'll be all about the operational energy, and the embodied carbon will become, even with repair and renewal emissions, it'll become a lot smaller a proportion. So this question of lifetime is quite critical, isn't it? What approach should we take to lifetime? Because there are standard lifetimes, aren't there, used? And then we can play with that if we want to. What's your view on that, Jeff?
Well, I mean, Peter Rickaby pointed out a while ago that the historic average for stock replacement for housing in the UK is 0.5% per annum, indicating 200 years as a typical lifespan for a dwelling. Now, there are obviously going to be cases where it's far shorter, especially when people have moved to crappy kind of, some of the mistakes that have been made in the recent past in construction, and some of the botched attempts at delivering low energy buildings can result in an unnecessary, at least repair and replacement work, too. But I think we do need to be assuming long lifespans. I think Letty's approach is quite useful in this regard with their targets, because they have separate targets for Module A for upfront emissions. So I think it's useful to have, they're the element that we can have most confidence over. So I think we should be aiming to put the minimum amount of emissions into the atmosphere upfront, while absolutely taking account of the performance of the building. I really have trouble with some of the stuff that I've seen coming out from some LCA folks in the past, advocating against, say, using triple glazed windows, in a new build because of the extra embodied carbon. I think there's a fundamental problem here. And this winter is a great case in point. If you decouple your notionally green building standard from what the public might expect, what public expectations might be in terms of, low running costs. You can see the Daily Mail headlines already, eco houses with $3 grand a year energy costs, those benefits are important. That's not to say that you can't have, if you look at the new AECB retrofit standards, for instance, the new heat pump focused retrofit standard, it's not to say that there's not a way to enable people to decarbonize now. But the critical thing about that standard is, which may not necessarily save much money upfront in terms of or quickly in terms of short-term running costs. It's not locking out. It's not locking you into crappy fabric. It's doing it in a way that enables you to make those other improvements over time. So I think we need to we can't do either or. And I think the thing is that the more you get into doing these calculations, the more you can find out very quickly that there are solutions we can take now which can tackle both. And this is the exciting thing from a designer perspective now, I suppose, because you can quickly work out, you can check your preconceived notions and your prejudices about different approaches to building, and subject them to scrutiny and see whether they stack up or not, and advise clients therefore from a much more informed position.
Thank you, Jeff. Great. John, do you have any kind of bugbears or insights into the use of lifetime?
Yeah, I think it's sort of important to note when we're talking about 50 or 60 year lifespans that it's the sort of phrase is a reference lifespan, and we're not saying that we should be designing buildings that last that long or only last that long, or that the buildings will only last that long. It's just that in order to be able to compare buildings with other buildings, you need to look at a fixed lifespan just so that you have kind of fair criteria to compare the two to. So even if you're doing carbon assessments looking at the embodied and operational emissions over 60 years, which is sort of what we mostly use in the UK, you're not saying that it will only last 60 years. The point is that just gives you a means to compare the emissions, because that forces you to look at what extra emissions there might be at the end of life and what the impact of that might be on your decisions. Whereas if you just say it's going to keep going forever, you ignore a chunk of emissions that will happen at some point. And I'm often making the point that you're sort of then looking at a slightly worst case scenario, but I think that's a good criteria to compare things on. So if you're comparing two different ways of making a building and two different ways of heating it and operating it, if those are slightly worst case scenarios and the one that you choose is the lower carbon, in reality, it can only then be even better than that. So it's, in terms of making decisions, it's really useful. And just in terms of being able to look at the relative things of different buildings, obviously, the longer your building lasts, the longer those end of life emissions are avoided. So that's definitely beneficial, and designing buildings that last longer or can be used or adapted more easily to keep being used for a longer period is definitely beneficial. So I don't think you should be advocating for not designing long buildings, and I don't think the sort of use of a reference lifespan is meant to do that. It is just to provide a means to let you compare buildings on a sort of even and fair basis.
Yeah, and in terms of longevity, I think components that have a problematic end of life issue, whether it's because they might be burned or decay, those really should be thought about perhaps as high value components, and components that shouldn't be overly complex like laminates or so on. They should be things that can be basically reused, repurposed, reused, and only in the last instance recycled, and ideally not burned or composted at all. Make them last forever. And of course, we've seen, timber buildings lasting hundreds of years, 700-800 years, examples abound. Tim, do you have any, maybe in the context of the stock model or something, about the issues around use of lifetimes in carbon model?
Well, I wanted to just talk about exactly that. Actually, the 60-year reference period is designed to be, now this isn't our choice, this is the RICS methodology, but it's designed to be long enough so that anything that's going to need replacement within the life of the building is likely to have been replaced at least once during that period. So it's long enough, but it's not too long, so that if you make it too long, then the embodied carbon that you're using, the figures that you're using, become a little bit irrelevant over time, because they get less accurate as things go on. And even so, everything will be improving. So hopefully you will still be able to make some reasonable judgments from that. But it's designed as a compromise to be a reasonable length of time, not too long, not too short.
Great.
The other thing about the stock model, well, the stock model has the stock model has a lot of information in it. I think we could plow into that a little bit later, but there's a lot of assumptions that go into that, and I think it's probably, there are some assumptions which are going to be a little bit difficult. If your aim is to be completely precise about the answer, then there's a bit of a problem, because we don't know. We've got a range of possibilities there. But if your plan is to compare buildings, which is better, which is likely to be better, and which is likely to be less good, well, then it will do that quite well.
I think this is a nice point you make there, Tim, that I want to elaborate on. It's the fact that whilst the numbers coming out of PH Ribbon are numbers, they're very precise. What's important is the broad conclusions, which then change the culture of our working, because, you know, and I guess this is where if you're making a certain target, if you have a target set and your project comes in on or just below or just above that, there's a useful guide. But what we're trying to do is to change the way our day-to-day design and construction practice works, which is a cultural change. So it's less about the numbers. It's about it being a tool, not a hard target. So there are a number of questions here which I'm going to save to the end rather than feed them in. It could become a bit too systems thinking, a bit difficult to manage. So I'm going to say some of these questions to the end. But Jeff, on your list of questions here, it's the third one actually. You talk about cradle to grave targets are important but problematic because of assumptions made in B and C. And this question of assumptions, but I've just underlined assumptions and supply chains in 25 years. So this is again about thinking over time. What assumptions should we be making when we're specifying products and materials now that we're saying, oh, well, you know, it'll all be sorted in a few years' time? Should we be investing ways of building that might be better now? Or
yeah, it's a tricky one. I mean, I think whatever we do, we should not lose sight of the need to, first of all, you know, of the fact that we have the ability to specify solutions that minimize the amount of carbon that's put into the atmosphere now, and that deliver at the same time a high performance building. I think one of the elements that's critical here as well in terms of life cycle components, which I'm not really satisfied with what I've seen, at least from in terms of the life cycle assessment approaches that are taken so far, is a consideration of the quality of the detailing, construction detailing, for instance, as well, and in the context of changing climate, you know, increased. I mean, there's a report done in Ireland a few years ago by the Environmental Protection Agency, which talked about the kind of horizontal rain that we have in large swathes of Ireland, becoming like Dublin and the Greater Dublin area has historically had a much lower rainfall level, more protected by the mountains, and different construction methods have been permitted. That report, the horrors when I read it, I remember was saying we're going to need cavity wall construction in the Dublin area as well. You know, I mean, reducing their consideration of these issues to requiring you know, much more masonry and much more embodied carbon as a consequence. But the point is, you know, look, I'll give you an example in this regard. I talked at the AECB conference in my talk about this the situation with PV panels, which PVs are a very important technology, but they're given that EPDs are just starting to become available for these kinds of technologies, we're starting to see massive variation for seemingly very similar products based on how the manufacturer has engaged and based on what the energy source is they're manufacturing, up to a point of, like, there's one module on the market that's 4 times lower embodied carbon than the rest, right? So if you go for the higher polluting one, the way it works, as I understand it now, is that you're meant to assume that the higher polluting one is being replaced with the same amount of emissions after 25 years, and then after another 25 years. So that's 3 panels basically in your calculations over a 60-year period, assumed to be the most polluting model, or the polluting model that you went for now. It just doesn't seem very credible to me. You know, I cannot see that we'll have any future as a species on this planet if we haven't made massive advances. Then I understand the precautionary principle, but you know, the reality, you know, and we can talk about how these targets, you know, I agree with what Tim and John are saying about not getting too caught up in the targets when it's with the numbers, the accuracy of the numbers when it comes to the 60 years. But the reality is, if the targets we have, the A2C targets, are, as per REBA, 625 kilos of CO2 equivalent per square meter, you know, over 60 years, people are going to get caught up in those targets, and the assumptions you make become really, really important. So it requires an awful lot of thought, you know.
It does, and of course standards can be a bit inflexible, and they can have unintended consequences, which is something I guess suggests that we need to, RIBA or LETI do need to get a good feedback loop going on what sort of decisions have been made on the basis of targets, and if there are unintended consequences, then we need to think about that. Yeah.
Can I mention something there?
Yeah.
That's an interesting example about PV, and what we've been doing on some of these calculations is we've been addressing that issue by actually talking to people about what they might actually do. Are they likely to actually replace? So some people may have an entire roof made out of PV. It does happen. There was one published recently in Passive House Plus magazine, and the question then is, are they actually likely to replace it after 25 years, seeing that the performance of the output of the PV might be, by some estimates, about 80% of what it is now, or some other estimates. You can get estimates from various manufacturers. There's not that much of a reduction. It seems to be quite good. So it sounds like the lifetime of the PV, as quoted by the manufacturer, isn't the figure you should be using in the pH ribbon. You have to take that with a pinch of salt, because of the owner behavior. They're not going to fork out that 3 times in 60 years or whatever it is. So a similar thing is also true for a rendered building. So we might say, oh, let's pick the lifetime from the manufacturer, say it's Baumit who creates a render, and that might be 17 years, 22 years. I think it's relatively short. It's quite surprising. Now, what they're saying,
their EPD is short, but their agreement cert, their EPD is 17 or 18 years, but their agreement cert in Ireland is 60 years.
Oh yeah. So with appropriate detailing and the lifetime could be a lot longer. I think you have to, as a designer, look at that and think whether that is really a likely scenario as well. Because what's more likely to happen is that they won't replace the whole thing. Who's going to take down all the render after 17 years and do it all again? I mean, that will damage it for a while.
Well, there's a similar conversations we've been having, and they're about windows and heat pumps. So if heat pumps technically are renewed every 17 years, we did ask ourselves whether, you know, is it likely that some components, you know, the compressor could be replaced or so on. And we said, well, you know, things move on, standard products will change, you know, and we thought it's probably most likely that something like a heat pump or any piece of equipment like that, that it would just be incompatible. So you would have to replace the whole thing. Whereas windows, you could argue that good quality timber triple glazed windows, you know, yeah, some of the sort of catches will break, and, you know, there's some fixings that might break, and maybe the odd unit might go. But are those really being, what's the lifetime on windows? Is it 20?
I mean, look,
30
even the first passive house, which had bespoke triple glazed windows made for it because they didn't exist. This is back in 1990. 25 years after that was completed, they did a destructive study on the building, and they measured the U values of the windows again, and I think there was one unit that where the U value wasn't what it was supposed to be. It wasn't terrible, but it wasn't what it was supposed to be. And they don't know whether that was a manufacturing flaw or whether it had lost gas over time. But the point is that 25, they concluded the windows were basically as good as new and would last another 25 years. You know.
Well, there you go. So when we see papers published, you know, arguing against the use of a sort of more high performance product with these sort of conversations, you can see we really have to take things with a pinch of salt, don't we? So before I go to the questions, the outstanding questions from the audience, Mike Mann's question in there has prompted me to ask a slightly broader question. So if we think about commercial buildings, say buildings where, so maybe the fabric and space heating becomes less relatively important than lights, appliances, equipment, and refrigeration, if you're talking about a sort of a supermarket or something. But if you're talking about something where, like a clothes shop or something, where panels and linings and decorations are sort of renewed regularly, do you think that one of the things what Mike was saying was, if we assume that materials will be increasingly decarbonized, does it matter if we don't practice resource efficiency? So should we be looking to design buildings that don't have kind of like stuff ripped out on a regular basis, because all of the kind of constant ripping out of stuff and recycling and, bringing more stuff in, and, that gives economic activity? What else are we going to be doing if we're not ripping stuff out and putting it back in again? And because it's all going to be magically, or should we be actually building a culture of restraint and making things last a long time and simplicity and so on? I mean, to me, it kind of seems obvious that we should be making things last and simplifying everything down. However, there is a point about what is going to happen in building and construction if we do put in place our principles of resource efficiency, building less, retrofitting more. I mean, I guess maybe I've answered my question. Anyway, what do you think about that sort of material flow? Is that a good thing economically if it's all green? Or
I mean, can I jump in? And I think it's important. Carbon is crucial at the moment. And then as things decarbonize, you could definitely argue that carbon calculations become less crucial, but resource use is an ongoing issue. And even if the things that you're putting in or replacing or whatever have a lower carbon impact in the future, they still have a resource impact, and there's still, unless everything that you use has magically been created by renewable, unless it's all plant-based basically, and then even that isn't necessarily a kind of cure-all, because it depends on what land use changes have happened to enable more products to be made of plant-based things. There's still a resource use issue, so you still need to be, we're concentrating on carbon, and I think right now we have to, but you've also got to remember that resources are a finite thing, and in many ways even plant-based resources are still finite in some ways, because there are still inputs involved, there are still land use changes. So it's still important to be resource efficient, just because you can't keep, there's not an infinite amount
there's a parallel here there's a parallel here with operational energy, isn't it? Because if we're going to move off fossil fuels to electricity for heating, then we need to build capacity to increase the supply of low carbon electricity. And if we're going to move off non-renewable materials to plant-based materials, we're going to have to somehow magically create the capacity for producing more you know, natural fibers and timber and so on without damaging biodiversity. And I think,
Yeah.
as we argued in our technical essay, The Wood for the Trees, that is a really potentially dangerous thing to do if you bring the capitalist market to bear on that. That's like a, you know, juggernaut being moved over. So we're very cautious about that. Okay.
I think it reminds me of the best analogy I've seen in this space, and I think it's in the context of net zero, for instance. There's somebody talking about being a net zero murder situation, whereby you murder someone, but you conceive a child to make up for the murder. You know, we can't let ourselves get twisted into these kinds of contorted positions. We do need to focus on carbon, but yeah, I mean, there are ways to tackle carbon that are kind of gaming the system effectively, and there are ways to do it that are actually giving a bunch of other benefits and taking pressure off this very fragile planet, you know.
Sure, thanks. So in the last like 12 minutes, I thought I'd ask some questions, and maybe you could take it in turns if you have a view on that. Tim, maybe you could have the first one. So Michael Simpson has asked, isn't the problem that we have a throwaway culture rather than refurbishing, in this case, talking about the heat pump issue? But I'm interested in this question about, do we have a throwaway culture?
Well,
Yeah.
we do. Yes, we do have a culture in which we don't expect things to last very long. And perhaps if we had a bit more of a attention on actually being able to repair goods, then that would be helpful, because we could, if a manufacturer said, we're going to honor this product for the next 20 or 30 years, we're going to produce spare parts for it, the actual workings of the spare part may change, but it will be compatible with what you've got. As long as you stick with us, that's going to save you a lot of money.
This is an interesting one, because I bought a Fairphone a few years ago on the basis they would be manufacturing replacement parts, little modules to allow you to repair your Fairphone. And it was great, but I think after a year they stopped doing that. And that's a highly ethical company, you know, that was really irritating. But then, so there's one thing is relying on manufacturers or companies to see that through over many years, which is pretty fragile hope, I think. But then the other one, yeah, maybe. I went to a friend's house a few years ago, and their parents still had their kitchen in high quality plywood, actually very nicely designed, from the 1960s. You know, they didn't require any support really. Even the hinges were all original, which is an example of like a DIY approach to it, isn't it? Rather than relying on supply chains to make these promises. Jeff?
I think on this point, the one thing that gives me real hope, is a really interesting concept, is change the model to encourage companies to sell services rather than products. For instance, have heat pump companies, for instance, selling you comfort and amenity of hot water rather than a heat pump, right? So basically, it's in their interest in that case. I don't know if this is wishful thinking, but the idea is that, is that it's in their interest for that piece of kit to last as long as possible, because they'll make more money even if they're getting a residual amount of money from you rather than a big upfront amount for selling you the kit. You know, that it's like the energy service company, kind of like an improved hopefully version of that. I think that has some promise, and there's a useful way of thinking there to kind of try and. Is
there a downside to that, do you think? Is there a downside to relying on that?
There can be. If you look at ESCOs or energy service companies as they've traditionally been conceived, have been problematic. It's been stuff like 15-year contracts for putting in a boiler or heating controls into a big commercial building, right? They'll track energy prices and they'll offer you maybe a 10% reduction compared to oil prices, or they might offer a fixed price. There's different ways of doing it. And what you have in some cases, the way the contracts have been set up, either the client doesn't get as much of the savings as they would otherwise. You know, it can not look that attractive. It can be kind of not as attractive as it should be for the client, or you can get into a situation where they end up running the hell out of the equipment by the end, when the end of the contract is coming up. So this thing, you know, and then so there's there are problems with it, but I think it's a promising approach, you know, to be thinking about the service rather than selling the service rather than selling the product, and then working at how you transfer, how you give people the option to transfer from one supplier to another is challenging. But this kind of way of thinking, I think, is promising. You know,
it's interesting in the pace of change. You know, what's required versus what has happened historically. But that's another thing. So okay, so there's a question from Claire Westron here, which maybe John could answer, and then Tim, because it's very relevant to you, and then Jeff. So Claire says, are the panel able to comment on the tools that are available to start looking at embodied carbon? Is PHPP ribbon the best place to start?
Well, I mean, we're probably all slightly biased in here with AECB connection, but I wasn't when I started using PH ribbon. I started using it because it does plug in nice and easily to PHPP, which is what I'm already using for assessing the energy use of buildings. I've used one-click LCA a little bit and PH ribbon quite a lot. They're both pretty good tools. They have sort of advantages to both. What I do particularly like about PH ribbon is because it is all based in the spreadsheet, is you can access everything basically. So you can see what's happening if you need to pull out specific sets of data or look at specific bits of the building or specific materials. You can very quickly find out what the carbon impact at different life cycle stages is for all of them. I don't know about other carbon tools. I know there's many more than just those two. What sometimes frustrates me with one click is that it's much harder to access all that information. There's a lot more happening sort of in the background that you can't interrogate, and I like to be able to interrogate things. If you want a sort of quick, easy fix, then it's probably great. But yeah, I think it's important that you can dig into what's really happening and you can dig into the background. And certainly when it comes to kind of auditing of things, which we haven't touched on, but I think it's important that there is a means of auditing these calculations, and it's not just us sort of doing a thing and sending it off without anyone checking. But that's very achievable with things like ribbon, because whoever's auditing it can trace, even if you've sort of tinkered with it a bit, they can see where your formula is linked to, and it's all the information you've entered is listed there, and all the sources of data, it's links to the EPD's sources or tells you where the carbon data comes from in the first place. So it's very traceable.
Great, thanks, John. Tim, I don't know whether you want to name check the standalone calculator, just in case there's a different audience listening. Yeah,
well, there's a different version which doesn't link to PHP, called the standalone version. It's the AECB. It's called the AECB Carbon Calculator, and that means it doesn't take information, which means you just have to find all the quantities yourself. But that's fine. That might even be easier in some situations. But I think it's a good place to start, because if you're doing the energy calculation in PHP, that's really where it's all going on. There's quite a stage at the beginning of designing a passive house building where you're just trying out ideas, and you're playing with a few different ideas, and it's a bit of a repetitive, iterative process where you try a few things out, and you might be using variants for that, or you might be using several PHPs, or you might just be changing the PHP a bit. Well, the nice thing about having the embodied carbon calculation right there in the PHP is that every time you do that, you only need to change the little bit you've changed to get a new result. And that, I think, is a useful and very helpful feature of the PH ribbon methodology, where it's all there for you. Also, I guess because it's us doing it, it's the AECB doing it, we're going to change things as the standards change. We've got a new organization, the BECD, who's organizing the way things are going for the whole of the UK. That's a built environment carbon database. They're a big consortium of all the major players. We're looking at what they're doing, and we're working with them to update when they actually get to the stage where things need to be updated in PH Ribbon. We'll be working to follow that through. So it's really for AECB members' benefit, and I think it's not a bad place to start. Yeah.
Thanks, Tim. I'll just point out that the use of PHPP is required for the AECB standards, not just a passive house. A passive house standard building would be needing PHPP. So would the AECB building standard, the new build standard, and so would the two retrofit standards, level 1 and level 2, both use PHPP. Jeff?
Yeah, on this particular point, I mean, I found Ribbon to be very useful. I've been able to do calculations myself in Ribbon, which is handy. I can see the value in the other tools like OneClick as well, but I love the fact with Ribbon that I can probe and kind of reverse engineer the calculations, understand what assumptions have been made. The transparency of it is its secret sauce, I think. It's so I think anybody who's got any, who's familiar with using Excel will find it a very useful tool in that regard. I think some of the tools out there, we've moved from a situation with life cycle assessment where it was very much on the periphery, and where, if you look at BREEAM, for instance, I had a conversation a while ago with somebody in the BRE on a BREEAM outstanding certified building that we were featuring in the magazine. It was a passive house premium project in Northern Ireland, and I was trying to establish from the BRE, because I couldn't get the information out of the contractor, whether the embodied carbon had been calculated. I would have thought for the BRE's flagship sustainability rating standard, the outstanding BREEAM, it would have been a requirement not just to calculate, but to actually have a target. But after about an hour on the phone with somebody from the BRE, a technical person from the BRE, they managed to answer finally my question as to whether embodied carbon calculation was required for BREEAM outstanding, and it's not. You get credits for doing it, for doing the calculation. It could be the worst polluting building in the world. You get the credits for doing it. And some of the tools, I mean, I don't want to label OneClick like this because it might be unfair, but some of the tools I think have been developed for a situation where just getting a calculation done on a building was their purpose, rather than giving you as a designer the ability to spot quickly and in a way that you really understand, what effect does it have if I change my wall, if I change the cement in my wall, from Portland cement to 50% GGBS, or if I change from a different timber frame variant to a different ICF variant or whatever. Having that information quickly available, I think, is really, really critical. And I think what we need to get to, and we certainly need within the kind of audience we have within the AECB, the thing we should be focusing on, I think, is literacy about embodied carbon and about whole life carbon. We all need to know this stuff really well, and so we can get tied up with whatever standards come down the line, whatever. But any work that people do in terms of understanding the issues will stand to you.
I think literacy, and that example of something that seems innocuous, like a sort of 10 mil leveling layer of a cement based material to put EWI on or IWI on, is it's a little hotspot in Tim's nice conditional cells, where you can see a slightly reddish kind of cell, which draws attention to the relatively higher embodied carbon. And that you can make decisions on that very, very quickly and easily. Talk to the manufacturer. Maybe you don't need a leveling coat. Maybe you could use an earth leveling coat. I think one of our members produces that for IWI. So yes, very, very fast and useful. We've got time for one more question. There's been various questions about the new AECB level 1 retrofit standard, which we have developed. And there's a video about it. So what we'll do is we email all participants with a link to have a look at that, among some other links. So the last question is from Debbie Haynes. she says, we will have to align with any approach that is brought in via building regulations. So obviously this is a Part Z question, possibly also with future future home standard. Do you have a crystal ball? No, but we can comment, knowing which embodied carbon tool is likely to align with this going forwards. Who was John, you were talking a bit about the progress of it. Was it a private member's bill that led to a proposal for a Part Z in the building regs, embodied carbon?
Yeah, I mean, I've had a very quick look at it. I don't know much of the detail, but just from looking at the sort of consulting document, there isn't a lot of detail in there yet. I think the idea is to get agreement that there should be a standard for embodied carbon, and then work out the details of exactly what that standard is and exactly how it's assessed later. I imagine that it will be similar to sort of the current situation, which is effectively there's overarching standards in, can I quite remember them? I think it's EN 19. No, I can't remember the number. There's an EN standard anyway that is sort of defines how embodied carbon assessment should be done, and sort of all the methodologies are based around that, whether it's the EU levels approach or the RICS whole life carbon methodology. So my
understanding of that particular point is that various software carbon modeling aligns with that, and pH ribbon can align with that as well, because it's just in the convention.
It does, and it's EN 15978.
That's the one.
Hey! You win.
Yeah, so you could, I hope anyway that they will follow that approach, that as long as the tool is aligned with the overarching standard, you can use any tool, and I think that would be a sensible approach. But yeah, we don't know what's going to happen. We'll kind of lobby for that whenever there's a possibility.
Great, thanks, John. Jeff, perhaps you could round up with a view about standards generally, perhaps.
I mean, you know, I think that it's a valid point that we would expect to see different software tools being able to continue to align with the standards. I think that's the kind of appropriate approach. I think you know, it's probably not helpful that that the UK has decided to go its own way, rather than, you know, having the UK and EU levels approach being one and the same would be helpful. Just from my perspective as a publisher with Irish and UK editions of a magazine as well, it's a pain in the arse. But the standards are important. But I think for now, honestly, I think people just get your hands dirty, do the calculations, familiarize yourself with this. Don't get too head up with that stuff. You know, you'll learn so much, and it's exciting. You know, you end up in a much better. I just feel, it feels to me like I'm in a much more confident position now as to you know, writing in a magazine. If I was a designer, I would be much more confident about what advice I could give to my clients about, you know, if they wanted to make reductions in this way, having been through, you know, having looked through a bunch of calculations, and even, you know, you're in a position where you identify a polluting product. You know, we're talking to manufacturers and who are engaging and saying, okay, well, we know we have a problem here. What can we do to fix it, short of closing our business down? You know, and so creativity comes from that, and I think it is an exciting and liberating kind of experience. You know.
Right, that's fantastic, guys. Thanks very much for sharing your time on this. All very insightful. A lot of positive comments going on in the Q&A and so on. So I think we'll wrap up now. So we'll send a few links. We'll email a few links afterwards. Jeff's talk, a talk on the level 1 heat pump retrofit standard, and maybe some links to do with training for pH ribbon. We could have put something in about that. So thanks everyone for listening, and we'll let you know when the recording is available to watch again.
Great.
Bye.
Bye.
Bye.